Okay, let's continue our discussion of the unit circle. We left off laying out the cosine and sine values for any angle with a 30-degree reference angle. Let's move on to an angle that has a 45-degree reference angle. So to generate these cosine and sine values on the unit circle, we're going to use the same idea. Let's start with first a 45-degree angle. So if this is 45, remember, we can think of or imagine constructing a right triangle here out of this. Since this is a right angle, that makes this also 45. And from our special right triangles, we learned that, okay, well, this would be side A, this would be the same because it's isosceles, and the hypotenuse is guaranteed to be A times root 2. So if you recall, we list our cosine and sine values here for our given angle. Remember, it's always cosine first, then sine. Cosine and then sine. All right, just using good old SOHCAHTOA, if I want cosine of 45 degrees, I need adjacent over hypotenuse. Adjacent, come on pen, there we go, over hypotenuse. The a's cancel and you get 1 over radical 2, which is fine, although it's usually not the common way we see it. Usually we would rationalize that denominator by multiplying top and bottom by root 2. And so I would be left with root 2 over 2. That's commonly how we write cosine of 45 degrees. The same exact thing is going to happen when we find sine of 45 degrees, right? Let's take a look. Sine of 45 degrees would be opposite over hypotenuse, but the opposite is the same. It's the same as the adjacent. So again, I'm going to get 1 over root 2 when those a's cancel. And if I were to rationalize by multiplying root 2 top and bottom, I would end up with root 2 over 2. That's my sine value for 45 degrees. So again, don't forget that this first number represents cosine of your angle, and this second number represents sine of your angle. Now, what we did in the other video is we developed the other three angles, cosine and sine values for the other three angles who had a reference angle of 30 degrees, and we did so using the special right triangles, but we did hint at the shortcut that we could use. So if we recall, an angle and its reference angle will always have the same sine and cosine values. So if I want to find these other angles whose reference angle is 45, let's picture the first one. This angle right here has a 45-degree reference angle. Let's see if I could draw it a little nicer. Because it's 45 degrees off the x-axis. Whether it's above or below, that doesn't matter, but if you're a 45-degree distance from the x-axis, then you have a 45-degree reference angle, and therefore your cosine and sine is common to every other angle whose reference angle is 45 degrees. So instead of drawing this special right triangle, labeling sides A and all that good stuff, we don't need to. We know what the cosine and sine is going to be. We know that cosine is root 2 over 2. Sorry, let me give myself a little space. Let me move my face out of the thing. There you go. Root 2 over 2, and sine is root 2 over 2. Now, I did draw this in quadrant 2 where, if I was labeling the sides lengths of this triangle, I would say, well, wait a minute, this should be negative A because I went left, and you'd be right. So if you're going to use the special right triangle route to figure it out, you'll see that. Or we can use that handy dandy trick that all students take calculus. And remember, what that's telling us is those letters tell us which trig functions are positive in each quadrant. In quadrant 1, all trig functions are positive. That's why both of those came out positive. Okay. in quadrant 2, only the sine should be positive. So that means cosine and tangent should be negative. That means the cosine, the first one, should be negative, and the sine will stay positive. Now this starts to get really quick and efficient. What if I draw this angle, right? This guy right here. Ooh, I should take a step back. I never officially labeled the angle for this first blue one. This would be 135 degrees, right? Because again, you can go all the way to 180 and then walk back your 45 degrees that you've overshot. 180 minus 45 is 135. So right here, what we figured out is we figured out cosine of 135 and we figured out sine of 135 pretty painlessly. So let's go to this next one. What angle is this? If I go all the way to 180 and then a reference angle of 45, that makes this 225 if you add it all together. So at an angle of 225, again, my options are create the right triangle, label sides appropriately using special right triangles, and then SOHCAHTOA your way to the answer, or I know what the cosine and sine should be for any angle whose reference angle is 45 degrees. Sorry, let me clean up some of that old stuff. Oops, that's old too, sorry. So for a 45 degree reference angle, your cosine is root 2 over 2, and so is your sine. So down here, this is guaranteed to be root 2 over 2 and root 2 over 2. I just got to determine, are they positive or negative? Now I'm in quadrant 3, where all students take calculus. That means tangent will be positive, but everyone else is negative. So my cosine and sine value should be negative. We just easily found cosine of 225 and sine of 225. And let's see how quickly we can find the one in quadrant 4. The reference angle, or sorry, the angle in quadrant 4 that has a 45 degree reference angle is 315. Because it's 45 degrees away from going all the way around, which would be 360 degrees. Now, because my reference angle is 45, I already know my cosine and sine. It's given. We already did the hard work. The cosine's a root 2 over 2, and the sine's a root 2 over 2. I just need to get the signs right. Oop, now let me move my face again. I'm sorry. So I just filled this in. I know the cosine and sine values. Remember, cosine always goes first and then sine. Because I'm in quadrant 4, all students take calculus. That's telling me that C, cosine, should be positive. So this first one's positive, but that means that sine needs to be negative. Everybody else is negative. And so we really quickly found cosine of 315. It's root 2 over 2. And then sine of 315 is negative root 2 over 2. And again, this might feel bizarre at first, but once you get the hang of building this, you can quickly find cosine sine for any angle on the unit circle, any common angle. Now, let me share with you, I'm going to leave the 60 degree angle to you. You've seen how to derive it for the 30 degree angle and for the 45. You would do the same to create the sine and cosine for your 60 degree angles. You would begin by thinking of the special right triangle, 60, 30, 90. You would first establish what is your cosine and sine, and then you would basically get the other angles around the circle for free. Anybody that has a reference angle of 60 degrees will have the same cosine and sine values. They will just be different by a plus or minus sign based on all students take calculus. So I'd encourage you to try that. But let me go ahead and just share with you the answer to quadrant 1. In quadrant 1, and really quadrant 1 is the only thing you need to know. So for a 30 degree angle, our cosine was root 3 over 2 and our sine was a half. For a 45-degree angle, our cosine was root 2 over 2 and our sine was root 2 over 2. When you take the time and go derive the sine and cosine and sine for 60-degree angles, you're going to find that you get a half for cosine and root 3 over 2 for sine. That's all you need. Now let me go ahead and share with you these special points real quick. At 0 degrees, see, remember at any multiple of 90 or 0 degrees like this, SOHCAHTOA doesn't work, but I actually know what cosine and sine are. If I'm on a unit circle, that means any distance I go is only 1 unit long, right? So this point must have the ordered pair 1, 0. And that's telling me right there that cosine of 0 is 1 and sine of 0 is 0. And up here at 90 degrees, that ordered pair must be the point 0, 1. Again, if I can only march a distance of 1 unit from the origin, so this is telling me that at 90 degrees, cosine is 0 and sine of 90 is 1. So I can quickly get those what we call quadrantal angles, any angle that's a multiple of 90 as well. And so I love the unit circle because what if the question says, hey, find sine of, I don't know, how about 240 degrees? Well, here's my thought process. First, let me find 240 degrees. Where is that? 240 degrees, well, there's 180. I would need to go 60 more to get to 240 degrees. And I just said the reference angle out loud. I just said that it's a 60-degree jump from the x-axis. That means this is going to be my cosine and sine values, guaranteed. I don't need to draw the special right triangle. I already did all that hard work. So if I want sine of 240, well, that's sine, right? It's always the second value. So I know the answer is root 3 over 2. What I need to just confirm is it a positive root 3 over 2 or is it a negative? So remembering that all students take calculus, anybody in quadrant 3 is only going to have a tangent value that's positive. And that means your cosine values and sine values must be negative. So this has to be negative. And I didn't have to draw any special right triangles. Simply knowing quadrant 1 of the unit circle and knowing how to navigate the wheel with your unit reference angles is all you need. Well, I guess that, and we need to remember that all students take calculus. That helps us get the signs right. I hope this was helpful. Look forward to seeing you in another video. Take care.